The purpose of this video is to go over the solutions for the Desmos activity inequalities on a number line. For screen number 1, it says to drag the point to any value that is less than 3. Screen 2 asks for the same thing. Screen 3 asks for the same thing. And as long as your points were to the left of 3, there were infinitely correct solutions. On screen 4, I'm asked, what would the graph look like if all of your classmates' points were shown along with yours? This is opinion, so it cannot be wrong, but many people did discuss the mathematics behind it, that it was less than or to the left of 3. For screen number 5, I see it revealed where all of the points were placed. Mine are dark and the others are light. How does it compare with my prediction? I would say it's correct. They are to the left of 3 and there were many points there. For screen 6, I'm supposed to drag the blue dot to a number greater than 1. Values are greater when they are to the right. See what happens on the next screen. I'm correct. There are a lot of points, and they're all to the right of -1. Some are barely over -1. And it's okay for predictions to be wrong, and then you talk about that. For slide number 9, it says, here are class results from another challenge. Drag each point to a place on the number line, indicating that a number that is blank. And so I'm looking at the points. I see that the points are going to the right, so it's probably greater than. It looks like nothing is going below 4, but I can't really tell if this point is equal to 4 or a little bit greater than 4, so I'm going to put 2 possible answers. For slide 10, here are class results from another challenge. Drag each point to a place on the number line, indicating a number that is. I see them going to the left, so it's probably less than, and it looks like the cutoff is a -2. Again, I can't really tell if it's equal or not, so I'll put 2 options. For slide 11, there is a card sort where they're going to be sorted in groups of 3, and there should be 2 left over. These are all of my cards that show numbers less than 4. These are all my cards that show values greater than 0. These are all of my cards that show values greater than -2. And these are my cards that show numbers less than -3. There are 2 cards left over. Slide number 12 does not have any activities to complete. Slide 13 has 2 number line diagrams. How are they similar and how are they different? Both number lines have a cutoff at -1, and they're shaded to the right. So this must mean that they are both, it involves greater than. The top number line has an open circle at -1, so that means that -1 would not be included. It would just be x's that are greater than -1. The bottom one, though, is colored in, and that signifies that the -1 is included. So it would be x is greater than or equal to -1. There's nothing to complete on screen 14, but in looking at the information, I feel pretty good about my last response. For x's that are greater than 1, that would have an open circle and be going to the right. For x's that are less than 1, it would have an open circle, would be going to the left. For x's that are less than or equal to 1, would have a closed circle and values going to the left. X's that are greater than -2 would have an open circle at that number because the -2 is not included and be going to the right, greater than. For x is greater than or equal to -2, there would be a closed circle at that value, and it would still show shading greater than to the right. And then less than or equal to 2 would have a closed-in circle at -2 and be going to the left. For which one doesn't belong, they could all be argued for different reasons. Some arguments for the top left is that this inequality is the only one that contains a negative value. The argument for the top right might be that the variable is on the right-hand side instead of on the left-hand side. An argument that might be made for the bottom left is it's the only symbol that has the possibility of being equal with the line under it. For the bottom right, could discuss that that's the only numerical inequality because it's numbers, not algebra. You could also argue that it's the only false inequality because 5 is not greater than 6. So all of these could be debated for different reasons, and you would include that in your slide.